This problem is similar to problem 33 from section 8.4. We're given a circle equation in non-standard form, and we want to rewrite the equation in standard form. We want to also give the center and radius of the circle and graph the circle as well. So the first thing we're going to do to get this in standard form is group the x terms together and also group the y terms together. And we're going to move the constant to the other side of the equation. So I'm going to subtract 16 from both sides of the equation. Now I'm going to complete the square. I'm going to add on the square of half of 8 to both sides of the equation. And I'm going to do that on both sides of the equation. Now to complete the square with y, I'm going to take half of the variable to the first power coefficient, add that to both sides of the equation. So notice in each case, I'm taking half of the coefficient of the variable to the first power. All right, so I have now forced two perfect square trinomials on the left side of the equation. So x squared plus 8x plus the square of 4 plus y squared plus 4y plus the square of 2 equals negative 16 plus 4 squared plus 2 squared. So when I factor this left side, I have the square of x plus 4. When I factor the y terms on the left side of the equation, I have the square of y plus 2. Now I'm going to actually square out the 4 and the 2 on the right side. So I have negative 16 plus 2 squared. I'm going to leave that as 2 squared for the moment. And this negative 16 and this positive 16 add to 0. And I now have this really in standard form. I can see that the center of the circle is the x-coordinate of this center is found by replacing x with the value that makes what's inside of this parenthesis go to 0. So the x-coordinate of the center is negative 4. Similarly, the y-coordinate of the center is found by replacing y with the value that makes what's inside of this parenthesis go to 0, and that's negative 2. And the radius is what I'm squaring on the right side of the equation. So the radius is 2, since I'm squaring 2. Typically, though, you would write the right side of the equation as a 4. I left it as a 2 squared temporarily just to emphasize the value of the radius. So my center is negative 4, negative 2, and my radius is 2. So I want to draw that circle. Okay, so I'm going to go in and plot my center of negative 4, negative. So starting at the origin, negative 4 tells me to move 4 units left. The y value of negative 2 tells me from that location move 2 units down. So my center is right here. And in this program I'm using, I can draw a circle very nicely. And I want the radius of the circle to have, I want the circle to have a radius of 2. So that means from the center, I'm moving 2 units. All points are 2 units away from the center. So that would be approximately what my circle would look like. All right, so this is how I would graph the circle, simply by plotting the center and then moving 2 units up from the center, 2 units down, 2 units right, 2 units left, and attempting to draw a circle using those 4 points as a guide. So again, the standard form of my circle equation is the square of x plus 4 plus the square of y plus 2 equals to 4. The center was the point -4, -2. We find those coordinates we find the x coordinate by replacing x with the value that makes the expression in parentheses go to 0. We find the y coordinate of the center by replacing y with the value that makes the expression in this parenthesis go to 0. And then the radius is whatever I need to square to get the constant on the other side of the equation. So I have to square 2 to obtain 4. So my radius is 2.